Hi guys, welcome back. Myself, I'm Arun, studying in SVC EC branch. Today here we are about to discuss modulation techniques used in TV broadcasting. The main contents are about introduction, modulation techniques, 8VSB, QPSK, QAM, COFDM, tabular representation, and conclusion. Introduction. Modulation is a process of altering a carrier signal. It is usually a high frequency signal to encode the information for transmission. It is a fundamental technique in telecommunications that allows information such as audio, video, or data to be transmitted over far distances efficiently and with a minimal interferences. Modulation technique. The digital TV broadcasting transmits a video and audio signal in a digital form. To ensure high quality, reliable transmission, it uses specific modulation techniques that efficiently encode the digital data onto a carrier signal. Here are the some common modulation methods used in digital TV broadcasting. That is 8VSP, that is 8 level vestigial sideband modulation, QPSK quadrature phase shift keying, QAM quadrature amplitude modulation, and COFDM, that is coded orthogonal frequency division multiplexing. So let us say about 8VSB. It is 8 level vestigial sideband modulation. Usage of 8VSB, it is primarily used in the ATSC, that is Advanced Television Systems Committee for standard, which is common in the United States and parts of the North America. How it works? 8VSB uses 8 discrete amplitude levels to represent the digital data. Unlike the regular amplitude modulation, which has symmetrical sidebands, 8VSB has one full sideband and vestigial sideband, reducing bandwidth requirements. Benefits: high spectral efficiency, allowing it to carry a large amount of data in a relatively narrow bandwidth that is resistant to multipath interference, which is particularly useful in urban areas where signals can reflect off buildings. The drawbacks of 8VSB is it is used as a less robust against signal degradation compared to other modulation techniques like OFDM. Next, it is QPSK, quadrature phase shift keying. The usage of QPSK, it is frequently used in the satellite broadcasting such as DVBS, that is digital video broadcasting satellites. How it works? The QPSK, that is quadrature phase shift keying, modulates data by shifting the phase of the carrier signal in four distinct ways. It is with each phase signals representing 2 bits of data. This technique allows efficient data transmission with a relatively low error rate. Benefits of QPSK: high spectral efficiency, meaning it can transmit more data in a given bandwidth, robust against noise, making it suitable for long distance transmission as required in satellite broadcasting. Drawbacks of QPSK: it requires a higher signal to noise ratio, that is SNR, compared to some other methods. Next, QAM, quadrature amplitude modulation. The usage of quadrature amplitude modulation, it is commonly used in a cable TV broadcasting as seen in the DVBC, that is digital video broadcasting cable. How it works? Quadrature amplitude modulation, it combines both amplitude and phase modulation. Each symbol can represent multiple bits by changing the signal's amplitude and phase. Variants like 64 quadrature amplitude modulation and 256 quadrature amplitude modulation allows high data capacity by encoding more bits per symbol. Benefits of quadrature amplitude modulation: it has very high data rate suitable for high definition, that is HD quality content and large data streams. Highly efficient in terms of bandwidth usage, allowing for multiple channels to be transmitted simultaneously. The drawbacks of quadrature amplitude modulation, it is more susceptible to noise and interferences. It it is has requiring a high signal to noise ratio for reliable transmissions. Now let us learn about COFDM, that is coded orthogonal frequency division multiplexing. Usage. The usage of coded orthogonal frequency division multiplexing is it is used in a terrestrial broadcasting in Europe, that is DVB-T and DVB-T2 standards. How it works? Coded orthogonal frequency division multiplexing, it splits the data across multiple subcarriers, each with a different frequency. These subcarriers are spaced orthogonally to prevent interference between them. The coded part means that error correction codes are added to protect data from the interferences. Benefits: extremely resistant to multipath interference and fading, making it ideal for dense urban environments. Scalable, supporting HD and even 4K broadcasts. Drawbacks of coded orthogonal frequency division multiplexing is it is too complex to implement due to the needs for many subcarriers and advanced signal processing. Tabular representation, it represents the difference between the four techniques, that is 8VSB, QPSK, QAM, and COFTM. The common stands these four techniques are having the 8VSB is having a ATSC, and it is used in the terrestrial, and the advantages are it has high efficiency and multiple resistant, and disadvantages are it has limited robustness in long distance transmission. QPSK. Its common standard is it is used as in satellites, that is DVB satellite. Usage, it is used in the satellites. Advantages are high spectral efficiency and robust. Disadvantages are it requires high signal to noise ratio. And the third technique is QAM, qualitative amplitude modulation. It is used in the DVB cables, and advantages are it has high data rate, and disadvantages are it has high sensitive to noise ratio. And other technique is the COFTM. It is used as a terrestrial network, and advantages are it has multiple path resistance and scalable, and disadvantages are it is complex to implement. Conclusion. In summary, modulation techniques in digital TV broadcasting are essential for efficient data transmission over various media. That is 8VSB, QPSK, QAM, and COFTM. Each offer unique advantages from high bandwidth efficiency to robustness against interference. By choosing the right modulation technique, broadcasters can ensure high quality, reliable digital services across different platforms. Thank you.